Alright guys, so talked about ionic compounds last week, but let's do a real quick review just to make sure we remember what we're doing. Remember with ionic compounds, we have this idea of electron, there we go, transfer. Basically, this is the cation is losing its electron and the anion is gaining that electron, or those electrons. Remember, our cation always comes first in our compound, and then the anion comes second. Our cations typically consist of metals, but can also have our polyatomic ions. Remember, our main polyatomic ion that's a cation is ammonium, NH4. But we also have, with anions, nonmetals, and we have our polyatomic ions as well. Remember, these we are going to do our cross and drop with our charges. So let's say we're looking at aluminum, which is +3. Oxygen's -2. Remember, they have to equal 0 once they're added together. Well, +3 and -2 are not going to equal 0. So what we can do is cross and drop our charges, get Al2O3, and there's our neutral compound. Just so you can kind of see the math. 2 aluminums means there's 2 + 3s because they still have their charges. And 3 oxygens is 3 -2s. Well, if I add these up, +6, -6, and then of course we would name it as aluminum because we named the metal, or we named the polyatomic ion. If it's a non-metal, we change the ending to IDE, so in this case oxide, or if it's a polyatomic ion, remember we just name it. So that's kind of the review ionic compounds. Let's take a quick look at our next type of compound, which are covalent compounds. Covalent compounds are a little bit different. Instead of them being a metal and non-metal, covalent compounds are made up of 2 or more nonmetals. So these will only contain nonmetals. So if you look at your periodic table, you drew a stair step, a black stair step line going between boron, aluminum, silicon, germanium, etc. all the way down. Basically, these compounds are going to contain only elements on the right side of that stair step. So like carbon, nitrogen, oxygen, sulfur, chlorine, bromine, that type of stuff. The other thing that makes these different is that they share electrons instead of transfer electrons. So with that, there are no charges. Remember, the charges for ionic compounds are because the cation's losing electrons, anions are gaining the electrons. In this case, no one loses, no one gains. Okay, so just to kind of continue looking at this, again, no charges to cancel out. There are no crossing and dropping. So if you see that down here, we are not doing the swap and drop or cross and drop. You are looking for 2 nonmetals to be in the compound. So like look at carbon, oxygen, nitrogen, oxygen, sulfur, and oxygen. What this also allows, because there are no charges, is that we can have 2 of these same elements making different ratios in our compound. So CO, carbon monoxide, that's what we have to be concerned about during the winter with old heating systems, or our cars heating up in the garage, is that those combustion reactions can produce carbon monoxide, which is highly poisonous. We can have carbon dioxide, we can have nitrogen monoxide, dinitrogen monoxide, and we'll talk about where the names are actually coming from in just a moment. Okay, so as we're looking at these, we have to understand that it's not like ionic compounds. Ionic compounds, I tell you sodium oxide, there's only one question what sodium oxide is. There is only one sodium oxide. That's determined by our charges. We cross and swap Na2O. This is the only thing that makes up sodium oxide. Versus with covalent compounds, let me erase this a little bit further. Versus with covalent compounds, if I was to tell you it was carbon and oxygen, and we'll do oxygen instead of names so you're not getting confused by the names yet, there's no way to know what these 2 are going to make because they can make different things. So the way we actually know how to write these compounds is going to be with what we call prefixes. Okay? Prefixes determine how many and what of each element is going to be bonded. So if we're looking at these, 1 is mono, and that is actually only ever used for the second element, which we'll talk about in just a minute. 2 is di, 3 tri, 4 tetra, and these from here will sound like your typical geometry names. 5 penta, like a pentagon, 6 hexa, hexagon, 7 hepta, 8 octa, 9 nona, and 10 deca. And we won't typically ever go above 10, so those are really the only 10 that you need to know. So di and tri are probably not too odd. Tetra, some people have issues with this. So that will be one you'll just have to memorize and remember. And then one is monos, not too hard either. So very similar to what you use in geometry, but also a little different as well. Okay, well, so how do we use these? First and foremost, when we're writing our naming covalent compounds, we need to remember that because we don't have charges, we're never going to simplify these compounds. So N2O4 is going to be left as N2O4. We cannot simplify it into NO2. NO2 is actually a completely different compound than N2O4. So again, a little bit different than ionic compounds and something you're going to have to keep in mind as we're working through these. From there, when we're naming these, we're going to name the first element just like we have been, except now it's a nonmetal. You are not changing the ending to IDE here. You're just naming the nonmetal. Then you're going to use prefixes if there are more than one of them in the compound, or more of the first element in the compound. So for example, NO2. N is nitrogen. We're just going to name nitrogen. It does not need a prefix because there's only one of them here. Versus here, N2O, we're still going to name it nitrogen, but because there is more than one with that too, we're now going to name it dinitrogen. Okay, and then the second element, again, we're going to name. We're going to use prefixes always for the second element, even if there is just one of them. And just like we do with ionic compounds, we're changing the ending to IDE. Okay, so let's look at some of these. Let's say we have C2O6. Well, we would look on our periodic table first and see, oh, carbon is on the right side of that stair step, so is oxygen. So we would say, oh, this is a covalent compound. So because this is a covalent compound, we're going to use our covalent naming rules, not our ionic naming rules. So from here, what we need to do is look at our subscripts and use our prefixes accordingly. By the way, your prefixes you may write either on the back of your polyatomic ion list or on your periodic table, or sorry, anywhere on your polyatomic ion list or the back of your periodic table. So you do not have to memorize these, just so you know. You can write them down on either your polyatomic ion list or on the back of your periodic table. Okay, back here. So looking at our prefixes, remember for the first element, we do not use a prefix if there's only one of them. We do if there's more than one. So because this is a 2, we are going to use the prefix di, and then of course carbon is just going to remain carbon. We're not going to change the ending for the first element. We just name it directly as it is off the periodic table, add our prefix as necessary. For the next one, we have 6, and we always use a prefix for the second element, so we are going to put hexa. And then, of course, oxygen is going to become oxide, just like it always has been. We are still changing the ending of our second element. Now, note if I put oxide here, I end up with this double vowel. In technicalities, we are going to actually get rid of that double vowel by dropping the A off the prefix and then just putting oxide in. So we end up with hexoxide. Though hexaoxide is okay. You don't technically have to get rid of it, but it is aesthetically correct to get rid of it and just have the hexoxide instead of hexaoxide. What you do with that is up to you. Okay, so let's look at another one. SCl4. So notice S and chlorine, Cl, are both on the right side of the stair step. So again, we are going to have a covalent compound, and we're going to name it sulfur. Notice there's not a subscript here, so there is just one, so we do not need the prefix. So we're just going to say sulfur. And then we see 4, which is tetra. Okay, and then chlorine becomes chloride. So we end up with sulfur tetrachloride. And again, because there's no prefix here, we understand that that means there's just one sulfur. Okay, so let's check out these guys. We have P4S5, and we're going to do this guy, and let's do that guy. And then you can practice the other ones on your own as needed. So because there is a subscript here, we're going to name this tetra. And then this is, of course, just phosphorus, so phosphorus. Okay, and then 5 is penta, and then S is sulfur, which we're going to change to sulfide. Okay, so tetraphosphorus pentasulfide is the name of that guy, which, yes, is a mouthful, but that's the best way we name it. We cannot put phosphorus and sulfur together to know how they bond because they, again, don't have charges like our ionic compounds do. All right, let's look at the next one. We have nitrogen and fluorine, again, both on the right side of our stair step. There's only one nitrogen, so we do not use the prefix mono for, let me write this, for the first element. Mono only ever goes with the second element. And then, of course, we have our 3, so we're going to say trifluoride. Okay, not too bad. Let's look at working in the other way. I wanted to point out this one particularly. Notice the prefix mono here. Mono will be used for the second element. The second element always requires a prefix. It's not optional. But the first element does not require a prefix if there's only one of them. So like if you go down here and check out this guy, notice there's no prefix in front of iodine. That tells me there's only one iodine. Penta tells me 5. Fluoride tells me fluorine, so I'm going to have IF5. Okay, if I go back up here and grab this one that we already marked, hexa, if I look on my prefixes, is going to be 6, and then of course boron is just B, so B6, monosilicide, silicide is silicone, and then that just tells me there's one of them. Notice I'm not crossing and dropping these numbers. The numbers are attached to who they go with in our actual compound. So let's check out this one. Dihydrogen, that tells me I have 2 hydrogens. Monoxide tells me I have 1 oxygen. Oh, look, we know that compound. That's just water. Let's do another one. Let's check out this guy. Dicarbon, again, tells me 2 carbon. Hexa tells me 6. Hydride tells me hydrogen, so 6 hydrogens. Okay, one more. Antimony, there's no prefix, so that tells me there is 1. Antimony is SB. Technically, it is on the left side of the stair step, but it is a metalloid, so it can act as both. We know it's acting as a nonmetal because we have the prefix in the name, but don't let that confuse you. We'll try not to put that on any test or quizzes. So we have SB, one of them antimony, and then bromide is bromine, and we have 3 of them. So not too bad? Okay, just very quickly, on your homework, you will have just covalent naming, but you're also going to have, there we go, a mix of covalent and ionic, just so you can practice making sure you can recognize the difference between them. My advice here, the first thing I would do, because we're also adding acids into this tomorrow, when you have multiple things put together, go through and highlight what's what. So in this case, we are going to make ionic compounds highlighted. Okay, and then we're going to leave covalent compounds as not highlighted, or just as they are. So in this case, how do we identify if something's ionic or something's covalent? Remember, ionic compounds start with metals R, NH4, ammonium. So I'm just going to go through my list and see, oh, sodium, that's a metal, that's an ionic compound. Copper, that's a metal, ionic compound. Nitrogen, oh, that's not a metal, that's covalent. I'm going to leave that one alone. Phosphorus, also not a metal, must be covalent. I'm leaving it alone. Aluminum sulfate, okay, aluminum metal, so I'm going to highlight it. Carbon's non-metal, I'm going to leave alone. Calcium's metal, going to highlight. Iron's metal, going to highlight. Carbon's non-metal, I'm going to leave it as covalent. Nitrogen's non-metal, I'm going to leave it as covalent. From there, we would go through and just name it using our naming rules. So ionic, we're going to name the metal or name the polyatomic ion. And then for the non-metal, we change the name to IDE or name the polyatomic ion. And then, of course, same thing can be said for if we're given the names. You'll go through and do the same thing. The names are actually a little bit easier because you can just look for your prefixes. So like in this case, lithium, metal, aluminum, metal. I'm going to highlight those as my ionic compounds. Phosphorus is a non-metal, or I can say, oh, there's a tri here. That's a prefix. That's only used in covalent compounds, so I'm going to skip over it. Sodium phosphate, metal. Lead, metal. Di, prefix, covalent. Tetra, prefix, or carbon, nonmetal. Ammonium, polyatomic ion, must be ionic. Silicon dioxide, di, or silicon, either way we want to look at it. Calcium, metal. Copper, metal. Okay? And then, of course, you go through and name them using our rules. So hopefully this helps. If you have questions, let me know. Thanks, guys.